Alright, today I'm at Menara HLX. This is Menara HLX main 11 kV HV room. I'm just doing a routine inspection and check in this HV room and LV room and as well as genset room. Okay? Okay, this is the transformer. Let us check the temperature. Okay, below 60. Load is quite low. Maximum is about 66 only. Alright, then the other one. This is transformer number 2. Temperature is just about 64. Always the yellow phase will be much more warmer. It's due to the middle. It's located at the middle because middle normally the heat dissipation at the middle core will be much more slower because at the left hand side you have another core and the right hand side you have another core compared to the red and the blue. At the side of it there's an empty space, so the heat dissipation is much more effective compared to red phase and blue phase. The yellow phase is less heat dissipation, so normally that is why the yellow phase is always higher. Okay, here we have a PCB panel. This is the incomer. Let's check the load. About 20%. Okay, then we have another incomer to 3 capping. Let's check the load. Just about 9%. Okay, here we have a power meter. Here I can see the reading, the current, as well as the phase angle. Alright. Overall condition is okay. We have the rubber mat in place, fire fighting system in place. The ventilation is okay. Here we have the battery. Battery is quite old. I think it's about time to replace. Alright, here we have the TMV meter. Incomer is 11.2 or 3. Currently is using about 66 amp. Alright, we'll proceed to the LV room. Alright, here we are inside the LV room. Okay, this is the LV room. So let us check. Okay, this is the incomer number 1, bus bar coupler, incomer number 2. This is going to the chiller room, and this one also going to the chiller room. Okay, let's check the calibration. Calibration expiry is on the 9th October 2023. Still long to go. Let's check the incomer number 1, MSB number 1, power factor. Power factor currently now is at 0.98, step 1 and 2 on. Let's check inside. We have a contactor humming. Okay, we have one. Due to long use or frequent vibration, humming is normal. So it could be some signs that this contactor going to get faulty soon. Alright, after that, let's check the MSB number 2 capacitor bank panel. The power factor currently is at 1.00. Here we don't have any step energized. However, I'm going to check whether there's any cable burn or any tripping occur at the MCCB. No tripping. Okay, let's close back. Here we have the changeover ACB. This is using Terasaki brand. It's a 4-pole ACB, and the control panel is here for the ATS. Currently the genset is not in operations, okay, so that's why you can see the TNB ACB is on, the genset ACB is off. Okay, this is the main supply and this is the genset supply. Once the genset is run, it is in operation, this light will light that up. Alright, I'm going to trigger the genset to run from this ATS panel by shorting these two cables, these two termination. These two termination is to call the genset to run remotely from the ATS panel. I mean, this is not the ATS, it's a changeover ACB. But in normal terms, we always call ATS panel. Okay, let's do it. I'm going to jump the cable. Genset seems not able to run. Okay, I think I need to go and check the genset. Okay. Okay, here we are inside Menara HLX genset room. This is the genset room. Now we are going to see what happened to the genset, why it cannot get started. Okay. Let's check over here. The voltage seems slightly a bit dropped, okay, compared to usual, and it's under boost charge. I think something wrong with the battery. Okay, let's try under manual mode and see what happened. Okay, we put manual mode and let's check. Not able to start. Battery seems to be weak. Voltage drop. Okay, let's check is a fuse solenoid contactor going in. It's either the fuse doesn't reach the combustion chamber or the cranking is not strong enough. Let's see. I put a manual again. Alright. The fuse solenoid master seems doesn't hold. I mean this relay. It should supposed to hold and the genset supposed to start. But it just cut in and cut off again. This is a fuse solenoid master and this is the start relay. The start relay doesn't hold for long, it just releases back. So it could be due to the voltage drop. Alright. like let's try one more time. Voltage weak, that's why I release back. It seems that it happened to be as when the genset cut in, the cranking causes a lot of voltage drop to the 24 volt DC system. As the voltage drop more than a certain amount, for example 15 volt DC or slightly lower 13 volt DC, when the voltage drop too much, it causes the contactor cannot hold anymore due to under voltage. That means the whole 24 volt system have a voltage drop. As when the contactor cannot hold, it will release back. Thus, that causes fail to start because all the control system release back their contact due to under voltage. So that is what happened. This genset has been replaced previously at 2016, now it's 2022. That means it's about 6 years each. Okay, that's all my sharing for today. So I hope my sharing will help you in your work and in your workplace. Thanks for watching and goodbye.